Hello everyone, this is Mr. H again, and welcome back to my YouTube channel. In this video, I will talk about finding the derivatives of exponential and logarithmic functions. But before we jump straight in to the very first example, if you haven't checked out the first part of this video, I recommend that you watch the first part of this video, and you can find the link in the description box. Alright, let's recall some important concepts that we will be using in answering a few examples later on. So how do we find the derivatives of exponential and logarithmic functions? So for all of this, provided that u is a differentiable function of x, we can find the derivative of e to the power of u will be e to the power of u times the derivative of u. And for the second one, finding the derivative of a to the power of u will be equal to ln of a times a to the power of u times du over dx, or the derivative of the exponent of a. For the third one, we have d over dx of ln of u will be equal to 1 divided by u times du over dx. And for the fourth one, we have d over dx of log base a of u is equal to 1 divided by ln of a times 1 divided by u times the derivative of u with respect to x. Alright, so we will be using these concepts in answering a few examples. Let's jump straight in to example number 1. Find the derivative of e to the power of 5x to the fourth plus x squared minus 11x minus 1. Alright, so to find the derivative of the given function here, d over dx of e to the power of u will be equal to e to the power of u times du over dx. So the first step is we take the whole thing, the whole function. So we have e to the power of 5x to the power of 4 plus x squared minus 11x minus 1 multiplied by the derivative of the exponent, or the u. Okay, so if you've watched the first part of this video about derivatives, so you can actually see from here that to find the derivative of this, we can, well, actually, if you notice, it's a combination of sum rule, difference rule, and we will also be applying the power rule here, okay, in which we will be getting the derivative of every term. All right, so for the first part will be the derivative of 5x to the power of 4, which is, we'll be applying the power rule. So we're gonna have 5 times 4 is 20 x, and then the exponent will be 4 minus 1, which will be 3. Next, the derivative of the second term, which is x squared. Derivative of x squared will be 2x. And the derivative of the third term is negative 11. And derivative of the last term, which is a constant term. So derivative of any constant is 0. So that means this factor stops here. And that is actually the answer. That's the derivative in factored form. So you can also put this forward before this is okay. All right, but technically this is already done. If you find it easy, so leave a comment below. And let's take a look at the second example. Find the derivative of the function f of x is equal to natural log of 5x minus 1. All right, so for this given function, we recall finding the derivative of ln of u will be equal to 1 over u times du over dx. So basically here, the 5x minus 1 represents u. All right? Okay, so to find the derivative, we have f prime of x. So be careful with your notation. So 1 over u, so it's going to be 1 divided by 5x minus 1 times the derivative of u, 5x minus 1, is 5. And the final answer will be f prime of x will be equal to 5 times 1 is 5 divided by 5x minus 1. And that is the final answer. All right, pretty straightforward question though. If you find it very easy, leave a comment below. All right, so on to our third example. Find the derivative of 3 to the power of x divided by 3 to the power of x plus 2. All right, as you can see here, the given function here, you can see the operation is division, and if you are going to recall one of the rules in finding the derivative, so immediately you think of applying the quotient rule. Okay, so once again, it's important and I recommend that you watch the first part of this video. Okay, so you can check out the link to that first part of the video in the description box. All right, so let's answer this question. So we'll be applying the quotient rule as what I mentioned earlier. So we take the denominator, which is 3 to the power of x plus 2 times the derivative of the numerator. So the derivative of 3 to the power of x is ln of 3 times 3 to the power of x times the derivative of x is 1. Okay, so it won't change if you write times 1, or if you don't write it, it's okay. So minus the numerator, so we take 3 to the power of x times the derivative of the denominator, which is 3 to the power of x plus 2, which is going to be, so derivative of 3 to the power of x is the same as what we got here. So it will be ln of 3 times 3 to the power of x. That's for the first term. But derivative of the second term, it's a constant. Derivative of any constant is 0. So whether you write plus 0 here or not, definitely it won't affect the result. Okay, so let's not write plus 0. And for the denominator, we take the denominator and we square it. Then we continue on with simplifying the numerator. So for the denominator, we can just rewrite that. So 3 to the power of x plus 2 and squared. And then if you can see from the numerator, we can factor out this one and this one because both terms have that factor. So let's take that out. So ln of 3 times 3 to the power of x is taken out. And if we take out that factor from this term, we will be left with 3 to the power of x plus 2. From this term, taking out that factor ln of 3 times 3 to the power of x, we will be left with this one, minus 3 to the power of x. All right, so the next thing we need to do is to simplify this part, right? So let me copy the denominator. So 3 to the power of x plus 2 squared. And simplifying what's inside the bracket. So let me copy ln of 3 times 3 to the power of x. And from here, we can see that you have 3 to the power of x positive, and you have 3 to the power of x negative. So that will be canceled out. It's 0. And we're going to be left with 2. So that is the derivative. So if you just want to rewrite it, so 2 times 3 to the power of x times ln of 3 divided by 3 to the power of x plus 2 squared. So there's another form if you want to rewrite this, and you can combine 2 ln of 3, and you can also make it like ln of 9. It's okay. So let's take a look at the next example. Find the derivative of the function g of x equals log base 7 of 10x cubed minus 3x to the power of 5. All right, so remember the rule in finding the derivative. For this one will be 1 divided by ln of a times 1 divided by u times the derivative of u, so du over dx. All right, so we'll start with, okay, g prime of x. So 1 over ln of 7 times 1 over u, just the whole thing. So 1 divided by 10x cubed minus 3x to the power of 5 times the derivative of u. So that whole thing is going to be 5 times the base 10x cubed minus 3x to the power of 5 minus 1 is 4. And then remember the derivative of this, so chain rule, guys. So derivative of the base, which is 30x squared minus 3. So g prime of x will be equal to 1 over, so ln of 7 times 10x cubed minus 3x squared, no, 3x to the power of 5. And then we multiply all of this. 5 times 30x squared minus 3 times 10x cubed minus 3x to the power of 4. And then from here you can see that we can do something about this too. So we can perform division. We're gonna have g prime of x equals 5 times 30x squared minus 3 divided by ln of 7 times 10x cubed minus 3x. And that is actually the answer in factored form. But if you want to write your answer or present your answer in expanded form, so it's going to be 150x squared minus 15 divided by 10x cubed ln of 7 minus 3x ln of 7. Both of these answers are acceptable. So one in factored form and the other one is expanded form. Okay. And for your challenge, grab your pen and paper and answer this question. Alright, so if you learned something new from this video, please give me a thumbs up, like the video, and share the video. And if you haven't subscribed yet to my channel, please do subscribe. This is Math Hub by Mr. H. You can check the description box for the related video links that I posted there. Once again, thank you very much for supporting my channel, and I'll see you on my next video.